seminar about natural building materials. And today I'm really happy that Richard Thomas is here to speak with us and explain us how he made a very interesting building in Paris using hempcrete as an insulation material. So I have come across the work of North by Northwest architect, like most of the people when I was doing research on hempcrete and where and how it was possible to use hempcrete. And I found out these very nice examples that is done by Northwest. And then I contact Richard, and he told me that, yes, of course, if you want, I can come and make a presentation for you. And actually, I guess he knows what it is to speak with students, as he's also at the same time professor as ENSAN, which is a School of Architecture of Normandy. So please, Richard, you can explain us what you are doing, how you were working, and what is this building that you did with hempcrete.
Okay, all right. Well, thanks very much, Matthew. Just to explain before I start, first thing is that although I am in France and I work in France, I am actually English. So I will be speaking probably English a bit too fast. And so I hope you understand everything, but I believe that it's being recorded. So maybe either we can come back on subjects that I haven't spoken out or you didn't understand afterwards. And if it's being recorded, then maybe you can watch it again and understand a bit better. So the other thing is that I have far too many slides. So I will go as rapidly as I possibly can through the slides, hopefully not too fast for you to understand, and then we'll just see how far I get before Matthew shouts at me and I will stop.
Okay.
So I will be speaking about hempcrete. I have two projects to present because we completed one in 2014. And the second we are just going through the process of handing over at the moment, and hopefully by the end of January it is actually handed over. So and they're both social housing projects, very small but small social housing. So yes, there was a bit of a problem with time difference this morning. I wasn't too sure. But what I have to say as well is that there's another difference between France and Turkey, is that we have a difference in climate. We're both in a temporal climate, but in Turkey, I understand your climate is a bit hotter, and therefore you are more concerned with how to treat being too warm in your buildings most of the time. Some of the time you can be a bit cold, whereas for us it's the opposite. We're mostly cold most of the time, and we're a bit warm some of the time, but not too much. And so that's it changes the aspect of how we build buildings and what we do. Let me go on. So now I don't know how is it going to work this. Well, I'll just have to press that. Right. Okay. So I just generally just explain in France what the conventional building is. It's mainly with concrete, either in concrete, which is mostly the majority of buildings are done with concrete walls with shuttering. There are concrete blocks, so obviously that a lot of types of concrete block, but the majority is made with concrete walls, using the shuttering, and it's so much so that they've developed a whole industry in making these kits. I don't know whether you can see my cursor, but making these kits you can rent or buy, all these different types of kits, just to make walls. They're put together and you pour in the concrete and that's it, you've got a wall. And it's a huge industry, huge. So the majority, and they're very powerful companies like Lafarge, who make concrete, who push on the regulations and set out the rules of how to do these, and therefore building regulations tend to follow this type of building, and that's the conventional, and sometimes it can be quite there's quite precarious ways of balancing these shuttering on the top of buildings and things, but big builders and builders in general in France know how to deal with it. So if you propose something else, they're a bit wary and they're a bit not too sure whether they're going to be able to do it. My cursor doesn't work at all. Oh, my keyboard doesn't work anyway. So I'm afraid I cheated a bit, and I went into Google Street View and had a look into different buildings in your country, in different towns, obviously, some further north, some further south, but just to see the general, and as I understood, a bit of research, I understood the majority of buildings are built with a concrete frame, with the floor and post and beam sort of system, and then the walls are then filled majority of the time with masonry, and then finished with some sort of render, cement render on the outside. So that's what I presume is what your conventional building type is. There's obviously alternatives, but the majority of building is done like this, which is
exactly.
Yeah. So what's important about that? Well, the problem is that we're going through at this moment. Apparently, they've calculated, or they did a calculation quite a while ago, but they defined 2020 as the year when the majority of or all the objects in the whole world, and if you separate the ones made by humans and roads and buildings and bridges and everything, every single thing, your iPhone, every single thing, if you weigh it up, it is now outweighing, it's going over the top and outweighing everything which is natural. So us, animals, trees, whatever, anything that is naturally made, apart from Earth, obviously, is being outweighed by us humans, which I believe is a real problem. It's we have to really start to try and think, well, how can we do it otherwise? And obviously, concrete is one of the main materials which is used unsparingly all over the world. So maybe we can do otherwise. Obviously, the real problem is to do with the population. We can quite see we have a real problem with population, and obviously, the more populated we are, the more we're going to need materials, the more objects we need going to use, the more cars, the more roads, the more etc., and it's it's multiplying at a very fast rate. So obviously we really, as architects, have to look at a different way of building, of using things. First of all, the materials that are not going to be a problem in future waste, or when we demolish a building, what we're going to do all the materials, and also possibility of reusing or recycling certain materials. And then materials that in the end can be just decomposing in the land. Certain vegetal materials that we can use, we can just put into the land and let it decompose in a very natural state. we'd really have to think and go into that direction. So how do we build unconventionally? Well, we're not experts, but our office, North by Northwest, has existed since from 2006. We started the office, and really from 2010, we started looking, and it happened purely by accident, really. But well, no, not really by accident. My studies and all my architectural studies that I did in Scotland, the beginning of the 1990s, were all of my projects were ecologically designed and being sensitive to the ecological problems we're going through now. But the opportunity to work in France happened from about 2010, when I went on to a school trip with the school that I work in, with a fellow engineer called Laurent Mouly, and we went to London, and by chance we saw a case. We were going to a research center, and they had a case full of hempcrete, and I had no clue what it was, the hempcrete. I hadn't seen this material before, and he knew. And we just happened to win this project as architects, win this project at Rue Mérat. And I didn't have an engineer at the time, so we said, well, let's get together and do it at hempcrete. So that's how it started. So 2 projects, one in Paris, in the center of Paris, in the 18th arrondissement, and the other one just outside on the outskirts. If you can see the line of Paris, that's the periphery, really. And then the outskirts, in between the waving of the La Seine, is Boulogne-Billancourt, which is quite a rich area, town, and so we have our next project that we're just working on at the moment. First of all, I just want to mention what is hempcrete, just for those who don't really know. Why we call it a crete, as in concrete. Well, basically because it's got 3 ingredients. One is an aggregate, one is a paste, or linking paste, and the third is just water. So we have the hemp, and what we call, well, there's different names for this, but there's the stalk of the hemp is taken, and then we take away the fiber, which is the outer coating of the stalk, and we're left with either a husk or a shive, or there's another word, an American word for it as well. So there's different words, but it's the inside of the stalk that we use. The lime is obviously excavated and then heated up. It's a bit of a problem for the ecological part, because to make lime, you take limestone and well, there's a whole process, a different process, but you have to heat it up at a high temperature, at about 1,000 degrees. And so ecologically, it's not a brilliant process, but what they're working on, especially in France, the main company that excavates and creates lime are working on factories where they use the heating system, but they're trying to use it with biomass or other forms of renewable energy to be able to create the 1,000 degrees that they need. So they're working on that. So this negative side of the process is trying to solve it. And then a little bit, a bit of water to mix it all up. So that's it's sort of like a concrete, but with more natural materials. The hemp itself, obviously you've probably heard about it, and we obviously talk about cannabis. It's not actually the plant itself that we use in our spare time. It's the it's a cousin of the cannabis, and anyway, we don't use the leaves, we use the stalk, so it's not even we're not even going into that. But it's a very old plant that's been domesticated for many years, and they've used it for all sorts of fabrics and ropes and even medicine, etc. And they still use it. Quality paper. Quite bizarrely, they make a lot of cigarette papers out of hemp, and even quality papers like money. The American dollar is an example of using European hemp, which is great for us. But and they use it in car manufacture. Cars manufacturers have to have a minimum amount of biosourced materials in their cars, and therefore they use hemp in the plastic to make up that quota that they're required. Also, the fact that it's not just grown just for the sake of it of using it. It's actually the main use is the farmers use it to clean up the soils, etc. So if they have a field of I don't know, sunflower of whatever, a field of sunflowers, they might have sunflowers for 2-3 years, and then they will rotate and grow hemp just to clean up and give all the nutrients. They don't need pesticides or anything. This hemp doesn't need any of that. And what it does do is put all the nutrients and then everything back into the soils to clean up the soil, and then they can start again with other potatoes or beetroot or whatever they want to grow. But they use it as a rotating and a cleaning up. So in the end, it can be considered a bit of waste material, which is good for us to use. If we actually take a zoom and go very close into this this husk or the shive, we can see all these little pits and holes, which is very important because these little holes participate in the definition of the fact that why it's not just an insulation or a passive insulation. A passive insulation is any wool, mineral wool or vegetal wool. If you even hemp, you can have a hemp wool insulation. You put it on the inside or the outside of a wool. Basically what it's doing and what you're doing in any wool, in any case, if you require an environment internally which is different to the environment outside, then any wall or facade, what it's doing is resisting those elements or the conditions outside, protect you inside. And so, as I say, in France, the majority of the time, it's cold outside, so we want to keep warm inside. So therefore, what we put insulation on the walls for is just to reduce the heat loss from inside the space going outside. And you in Turkey is probably the opposite, where it's very hot outside and you want to keep that hot outside, so you have colder spaces within inside. And so this heat transfer, you put insulation materials on, and what you're doing is making a bubble, and that's all it does. The insulation just sits there and it's inert. It doesn't do anything. It's completely passive. For all it's doing is reading. Whereas hempcrete works, it does that, obviously, that's its role as well. But what it does do is it also works with the humidity. And these microscopic pores, whatever, are able to absorb, they're like sponges, they absorb the humidity that's in the space, and when the space or the internal space is very humid, what it does is it absorbs the humidity, turns the water vapor into liquid, and then stores it in these little pores. And then once the air becomes very dry, then it then transforms the liquid into water vapor and then releases it. So basically, you're getting a very constant level of humidity in the space. And there's a direct link between humidity and temperature in a space, which is very important. It's very complicated, but there is a relationship. And therefore, if you regulate the amount of humidity in a space, you then regulate the temperature. And that is, and it's a phenomenon, it's an inertia phenomenon, which is very important. It's not the same as an inertia of a stone heating up and keeping the temperature and then releasing it. It's a different type of inertia, but it's still inertia in the fact that there's a phase of a different phase. So that's how. And on the other thing is, which is very important, is when it does absorb this humidity and turns it into liquid, there's a change of phase, a physical change of phase. And that physical change of phase releases an extra energy. And that energy is in the form of heat. Therefore, it's heating up slightly, several degrees, the temperature of the wall itself. And vice versa. So when it releases, the liquid changes from a liquid to a vapor state. There's a release of energy, and everybody, well, we should know that once you're in a space, your thermal comfort is related to one, the temperature of the air, the ambient temperature of the air, but also the temperature of the surface of the walls, because it's a radiant heat. And basically it's the difference between the two, the surface area of the walls and the ambient temperature, and the difference of the two, it gives you your felt, or your felt temperature, the temperature that you feel. And so the higher or the more you reduce the difference between those two temperatures, the better it is. And that's what hempcrete does. It heats up the walls, and therefore you have a more comfortable feeling. So you can be in a space that is only 19, 20 degrees centigrade, but because the difference between the two is less, you actually feel better than if the temperature is at the air temperature is at 23 degrees, but your surface air temperature is only down at 17. So other materials can be able to do that. So we rely on this inertia to be able to contain the temperature all the time. And the other thing, obviously, the last thing is obviously the amount of carbon dioxide that any building, I mean, this is in French, but you can see on the blue that's the construction. This is in 2005, and then for 60 years of the life cycle of the building, the amount of energy that's used. We've now, with regulations, reduced that amount of energy use, but we've gone up in the amount of energy that we use to build the building. Whereas if we use it in hempcrete, then we're reducing that amount of carbon dioxide which is released into the atmosphere. Just to say that hempcrete is not load bearing, so it's just an infill. You need another type of structure to be able to keep it up. Although it sets, and it sets very hard, but we normally use it with timber framing. So I'll go on to the project itself. Well, the whole of actors. There was a lot of actors, but what's important is this our design team. There was us with LM Engineering, Laurent Mouly, and of course the building control officer, which is quite complicated in France, but I'll not go into it. Actually, is found within which is in the 18th arrondissement, which is going through an urban mutation. So, quite old and derelict, or not derelict, but very old. They're getting pulled down, and little sites are becoming available to then build up new buildings, which is exactly what our case is. Rue Meyrat is there, goes right across the sector. Now, what's important? Well, just to say that our site is the road side, or the facade facing the road is on the north side, which leaves us a little tiny garden on the south side and the south facing, which has sort of instigated our difference. We have a two facade contrast. One is a very sober render finish, and the other is wooden cladding. What's interesting, we can see an aerial view of Rue Meyrat, which is here, and our building is just here. So it's part of a building block, which is very typical in France. So all these facades turn out on the outside, and we have an internal core space in between these places, which create a sort of a little microclimate as well. I'm just going to have to move these up, your images. I'm sorry. Go to this next slide. What's important is just to say it's this area, the 18th arrondissement in Paris. So the underground is full of holes. Okay, there's gypsum also all over the place, and there's big holes and cavities within the underground of this area. Okay. So this area is absolutely inundated. It's like a Dutch cheese, as we call it, or a French cheese full of holes. This is what, and so the owners of the land, if they want to sell it, they have to fill them up. By law, they have to fill these with concrete or whatever, which is very expensive and time consuming. But to be able to build, so for these buildings, all these projects that have gone on in the rest of the street, there's a lot of new buildings like ours, exactly the same condition, but they're all done in the conventional building technique. They're all done with concrete walls, etc., and concrete shells. But for them to actually build and hold a building up that's about 20 meters high, 20 or 25 meters high, well, they have to go down with piles to about 50 or 60 meters just to hold up a building that was 20 meters high. Now, with Laurent, we thought this was absolutely ridiculous. Because the buildings are too heavy, it's stupid. So we tried to go for an alternative, and so we decided on a steel frame structure, principal steel frame structure that maybe you can see, but this is the design that is on the side, and then that steel structure then held up a timber frame structure on the facades and on the roof. That was the idea, to make it lightweight. And then we used hemcrete on the facades. So in detail, obviously because it was unconventional, we had to draw all the details, and these details were drawn very early on in this stage to see how we could integrate the timber framing and how the thickness would work with the hemcrete, because it's filled in, but it's also larger than the actual the timber framing is actually buried within the hemcrete, and so how to do the different details, and also very importantly how to have the different finishing, because as an architect I didn't want just one type of finish. There was a render, a lime render wash on the outside, on the roof, on the roadside, but on the garden side we wanted a timber cladding, and also on the roof and on the upper level, very characteristic in Paris, with a zinc finish, a zinc cladding finish. So all these details had to be sort of thought through before we actually could go into the building, because these had to be explained to the builder as well for them to price up. So there was even a lot of work gone on to onto the window framing. There was a whole window frame that was inserted in before the window frame itself was inserted. Well, unfortunately, it wasn't exactly made in the end, because exactly like that, it was all done in one piece, but it was thought through. And also we had shutters that were to open, and we wanted to hide those behind certain grooves and things. So aesthetically, we had to think about it, and all the junctions, obviously, with the different, because even though we had a steel frame, the floorings themselves were made out of concrete, thinner concrete. So what we had to do is to make sure that, and that is the other advantage with the hemp, is that the wall is actually continuous, because the hempcrete takes up the whole of the thickness of the wall. It's only 30 centimeters on this case, but the whole of the wall is insulated. Therefore, there are no thermal bridges, cold bridges, thermal bridges, which is you have a lot of heat loss. If you have a typical concrete wall and then you put an insulation on the inside of it, well, the junction between the floor slab and the wall creates this very problematic thermal bridge. And there's a lot of energy goes through, and it is lost through this, the heat transfer through these points. So we had to make sure that these were avoided. The whole fabrication of it, well, first of all, we had to put the steel framing up, and then we put corrugated sheeting, profiled sheeting laid on this framing to be able to hold the floor slab. The timber framing was then assembled. We put an internal finish straight away before. This internal finish was called Fermacell. It's a mark. They're actually, it's called gypsum, but it's made. Oh, what's the word? Wadding. They're made out of wadding, paper wadding. So the gypsum boards, typical gypsum boards, have to be heated up. It's like the lime. They have to be really heated up, and so it uses a lot of energy. But the advantage of these boards, these Fermacell boards, is the fact that they're porous, and that was very important to be able to allow the transfer of this humidity between the internal space and the hempcrete walls. We could have done a lime render on the inside, but because it was social housing, the fixing of just a mirror or a picture on the wall would require certain fixings and very long screws and things. And I didn't want that. I wanted something that they could come along and just fix with any type of fixing. And so this was a bit of a compromise, because it's not so porous, but it still works. And then the hempcrete is then projected on, and then once it's dried, we then cover it with whatever covering. This is with the lime wash render, but whatever cladding you have. Well, very quickly, the project itself it's very simple. There was only 4 housing units in this very small project, experimental project. So it was very simple, but there was a duplex sort of building on the 4th and 5th floor, which had about between 5 and 6 bedrooms. But the general layout was pretty easy, with the bedrooms on the roadside, because there was a calm road, or it's a road currently being made into a pedestrian road, so it's very calm. And then on the solar side, the sun where it comes in, on the garden side, the main living space. So that was the building that was there, that was going to be, well, was demolished and left an open space. The building, just to mention and go back to what I said about the foundations that went down and all the neighbors in the road that went down to 40, 50 meters. We had a technical basement and there was about 3 meters just to put the heating space and stuff. And we had superficial foundations underneath that went 3 meters. So in all, we had 6 meters of foundations compared to the 50 or 60 meters, whatever it was, for the neighbors. The reason is that this type of construction with the steel framing, whatever, is 5 times lighter than conventional concrete walls. There was no crane, no side crane. We had a temporary crane come every day, close the road, but we were able to recirculate. So he came from 8 o'clock in the morning to 6 in the evening, and he just able to assemble all the metal. It only happened 5 weeks. Everything was done. So everything was built up. The corrugated or the profiled sheeting was laid down. The floors were then laid. The concrete floors were then set with a big pump going all the way up. And then the timber framing was put in with these window framing, special window framings with the space for the shutters to go in, and the roof itself, so which was in timber framing as well. And then we put these Thermocell boards on the inside. So this was then exposed until, just a little detail. We had to, the difference between normally the what we call the air tightness in a French building normally is on the inside between the insulation and with a vapor barrier between the insulation and the internal space. Because we want this transfer of humidity, it had to be on the outside. So it happens with the render on the outside. So we had to make sure that the connections between these windows framings and the outside air tightness with the render was well established. So then they came in with the hempcrete. There's 2 machines basically, one for the hemp itself, the dry hemp, and the other with the dry. On this case, with the dry lime, which is then put in, and then basically there's two ways of moving. I think there's 2 ways you can see with this. This hose here, which was specially made. There's 3 pipes that go in. One is for the hemp, one is for the lime, and the third one is just a little one with the water. So everything is mixed within this sort of fireman's hose here, and then it comes out. Now there's 2 ways of either you project horizontally and then it just sets, or you can just do temporary boarding to shutter it. It lasts for a couple of minutes. You can do it, and so he had a team, one with who was putting the hemp in, and 2 other guys just changing these and going further up and up and up. Every 2 minutes, and you can change the shuttering. You can turn it off because the hempcrete sets quick enough. So that's the hemp that's filled in, and then we leave that to dry. We leave it to dry for maybe a month, 2 months, but it doesn't matter because everything can continue on within the site on the inside, because now the the working conditions on the inside are favorable and they can carry on working. So the actual planning of the building site doesn't change at all. And then all the coverings are put on, the internal finishings and the installations, technical installations are put in, and then we have a handover at the end. So this is the wooden paneling, wooden cladding on the garden side, with the attic in the zinc, and on the roadside with a sort of a sober, simple render. And there you go. And then the inside, well, all the finishings are very much similar to any other project. The advantage is the fact that they enjoy a very thermal comfort, with very little energy spent for heating. I'll go on to the Ambient Core. I've got less slides for this, so I'm trying to change the position of the screen thing, so I can't tell. There you go. So this we're just, as I say, handing over. Oh, there's the team. This time it's not one main contractor who's doing the whole thing. This time we have several. We call macro load. There's several builders all working together, but the same design team together. We're on the outskirts. We can just see Paris there. There's a metro line that comes all the way here, so we're quite close to any for the social housing. But we have an east-west orientation on the site. The site is very interesting. It's called, in French, as Mathieu knows, we call it this dent creuse. It means the missing tooth. It means you have a line of buildings, but you have one gap in the middle, as if it's a tooth is missing. And this was very important because the economy that we gained on the foundations on Rue Merat, we didn't have in this case because the ground is fine. There's no problem with it. So any lightweight building wouldn't make huge difference in the foundations, although they are lighter in general, but it wouldn't be a huge economy. Well, the advantage of this is because our building has two neighbors, if you like, on both sides. In reality, we only have two facades that we're having to insulate because we're gaining on the thermal resistance of the two neighboring buildings, which was huge for us because what happened was we were able to reduce the thickness of the facade of the envelope on both sides, and we reduced it down. So this facade, the facade on the garden side and the facade on the road side, we were in Rue Merat, we were at 30 centimeters, 33 centimeters of hempcrete, and this we're down to 23 centimeters. Now that 23 centimeters plus the Fermacell on the inside and the render on the outside makes a wall of 26 centimeters, which is virtually impossible in France now, with all the regulations that impose the amount of resistance. And we were able to gain so much meters squared. It's not a lot of difference of centimeters, but if you calculate it on 8 stories up, which is what we're doing a ground floor plus 8, which is the highest hempcrete building in the world now. We were able to gain a lot of surface area, which the Social Housing Association were able to rent. Therefore, our budget for the work went up because we were able to produce more surface area. And that's how we managed to do something a little bit different. So the demolition of the existing house, the basement went, well, the foundations went in the end, we didn't have a basement. They installed the site crane that only went, was a limited time. So it was only there to make up the main framing. Now this time, we didn't have a steel framing. We went for a traditional concrete because of this the story about the foundations. But basically, there are 3. If I go back to the plan, basically you've got the 2 party walls on either side, which are load bearing, and then this load bearing wall, which is a bit of a zigzag wall in the middle, and all the floors then span from these, and that's how the construction works, basically. And the builder, we decided in the end with the builder that he would make these into prefabricated concrete walls. Basically, they're two skins of concrete, and then he puts them those into place, and then he pours the concrete in between, making up the whole of the wall. And it's the same with the slab. The slab has a very thin thickness. He puts that in place and then pours another screed over the top to make up the slab, the floor slab. And so this was very quick. He was able to do these very quickly, and put these walls and these floors and lay them. So the floors were already just placed, put into place, and then they filled up with the screed afterwards. And so this went very relatively quickly, and also so quickly in fact that also the other thing was to add on the timber framing on each of the sides, so the road side and the garden side. These were prefabricated as well, and they were prefabricated timber framing with the Fermacell panels. So the Fermacell panels were already, which was another time saver. And then also at the same time, he had the window framings, because some of them were quite large. They were delivered at the same time, and they were all lifted into place. So in fact, we had a series where the concrete main superstructure wasn't actually finished, where he was building up those. We actually weren't to the top before he started putting these prefabricated panels in with the Fermacell already fixed in place, and the windows at the same time. So he was building up as he went along, and the whole thing was a very quick process. And then we had the hempcrete, sorry, which obviously gave the same advantages of Rumira, and very easily. Just to say, and these are the two machines were there. The hoses that come from these, this is another advantage. The hoses that come from these machines can go up to 50 meters, no problem. So again, they have this fireman's hose where the mix is done. This time they mixed, they mixed the water within the lime at one time, and then they just had a small amount of water at the end. But the mix was the same. It was just done at a different time. And this time they projected. They didn't use any boarding or anything. They just projected, and it sets in place immediately. I lost it again. Okay, and so that is the hempcrete being put in place. That's his bust there, and just to show that it was a very thin 23 centimeters of thickness. And you can see and these boards, these Fermacell boards, are there permanent. All you have to do is put a paint on the inside, or screed the joints, obviously, but the paint, a microporous paint on the inside, and the finish is already done. So it's very easy. Even French television came along to film us at one point. And just in terms of energy, the other thing was that we had a lot of showers in the project. So every shower gives, when you take a shower, it the grey water or the dirty water goes down, and it's lost heat. It just goes away. So there's a system now that we use to recuperate the energy. So as the water to feed the cold water that feeds the shower goes past through, and the heat transfer is taken from the old water that's going away to heat up the shower. And therefore you don't need to heat up so much of the water to be able to take a shower. So it's a 30% renewable energy system. So it's very good. And then the installation of the insides starting to go while the hempcrete was drying. And then the finishing, once it was dried, the finishings could be put on the outside. Mainly the majority of it was lime wash, but on the roadside, we have 2 stories of brick, facing brick on the outside. And there you go. That's so basically the conclusion is that well, we're building in an unconventional way. What our objective is obviously to make it a very conventional way of building for future generations. There you go.
Thanks a lot. Really, thanks a lot for this presentation, Richard. It was really good and really interesting, I guess, for everybody. And one thing I was really happy to see is all these details that you show as part of your design process. This is exactly what I am trying to teach to students, that detailing the material, the construction system is also part of the design process, because it is how they will be able to use the materials that are not conventional, by showing that it is possible through designing how to use them. So thanks a lot for showing all these drawings. And now, if anyone has questions, please. I think it's time to ask to Richard if you have any question about how he did, about the material, how it happened.
I have a question.
Yes, Dennis.
First of all, thanks for the nice presentation.
Welcome.
My aim is to use hempcrete in my research center in the design class, according to Matthew teacher's advices. So I couldn't understand very clearly that how you use steel structure with hempcrete. Is that inside the hempcrete, or inside the hempcrete there is just the timber structure and the steel structure carries the whole thing, whole building?
Okay, well, it's a good question, because obviously we think that because of this humidity and whatever going on, that it might be dangerous to put metal. I didn't mention it, but the majority of we do use timber framing, but we can use metal as well. In fact, in my second, I have a house in Normandy that I'm doing at the moment. I'm putting a bit of hempcrete, and I'm using just standard partition metal framing to do it. But in the case of Rue Merat, the steel framing, at times, some of it, sometimes not. In fact, I don't know whether there was a detail showing it, but sometimes it was embedded completely into the hempcrete. And there is absolutely no problem with that, because the hemp is like a sponge. Any form of humidity that is within that wall, the hemp will then absorb it like a sponge. And so this is why, in fact, another element which is quite important, even the timber, but the metal, there's absolutely no problem. The metal, as long as you keep it away from the rose point, the humidity point, it can't be too close to the surface area of the outside, because you might have a variation of temperature, which can be a bit damaging, or a condensation which will be produced on the metal. So as long as you're, I think it's 8, we decided 8 or 12 centimeters between the metal and the outside atmosphere, then you're fine. There's absolutely no problem with it. But the other thing is that the fact that we know that one day when we take away these the wall, or we demolish the wall, the timber in it will be exactly like it was when we first constructed it, because the timber doesn't absorb the water or the humidity. It doesn't get destroyed. It's the hemp that keeps it all, and therefore the conditions of the wood afterwards, in 100 years' time, when they take the building down, will be exactly the same, and they can reuse the concrete. But the metal is no problem. To answer your question.
Okay, thanks. So without any timber framing, we can use steel structure with hempcrete.
Yeah, as long as you keep it away from the, you know, there's a distance between the external atmosphere.
Yeah, okay. Thanks a lot.
Thanks a lot for this clear answer. And I was not totally sure too, so that's the reason why when I knew she wanted to use this material like this, I said that she could directly ask a question to you. So
Absolutely.
that's really good.
No, it's the condensation that you have to avoid with any metal.
Yeah, exactly. So is there any other question?
Just to go back to the detailing, the detailing is very important.
Exactly.
Because what you're trying to do is to produce a certain atmosphere within a space, whether it be you're trying to create a cool space within a hot environment or a warm space within a cold environment. You're trying to create an atmosphere or an ambiance within this space. So, okay, you come up with a solution with the envelope or the facade to be able to do that. But then you have to start putting your architectural cap on and start saying, well, okay, but how does it look? How do I get it to look how I want it, but do the role that I want it to do at the same time? And therefore, you've got to draw the details to be able to do that.
So thanks. I see there is no more question right now. Okay. So thanks a lot again, Richard, for this really nice presentation. And I hope the students really learn a lot about it. Now I see that Florian arrived. Florian, can you hear me?